This is the opening joke. That is what I used to look like before lockdown. Um, but yeah, thanks to HashiCorp, the community, and everyone for putting this together, and all the conversations are great. Um, and also for making that wonderful speaker card with my old headshot. So I'm just going to start off by just sort of addressing a little bit of the terminology here. I'm talking about a thing called blank apply. It's possible that some of you know what I'm talking about. I'm going to go on a little bit of a journey and talk about why this became a thing that we even cared about, and then sort of what this sort of technique means. This is basically a story of necessity and invention. So if you're familiar with this icon, then forgive me, I'm going to do a little bit more talking. This is the AWS icon for an IAM role. So maybe you're also familiar with service quotas. Maybe you already know the answer, but the question here is, what is the default maximum for IAM roles? It's kind of high because you're supposed to have a lot. If you know about other maximums, VPCs, for example, in AWS, the default maximum for those is 5 per region, and they don't cost anything. Just like IAM roles, they don't cost anything. But of course, 5 VPCs is probably enough. You can always ask for more. IAM roles, they give you more than that. Is it 20? Is it 50? It's actually a lot more. AWS sets a limit on the number of buckets at 100. That's another thing that's actually free. Once you start storing, of course, you pay S3 storage costs. But simply having the buckets doesn't cost anything. And the limit there is 100 per an account. Roles are important for how EC2 instances talk to other things. Different AWS services communicate with each other and prove that they're authorized, associated with policies. The number of load balancers you can have per a region is 50. The number of auto-scaling groups is 200. And IAM is global. So obviously it should be more than that. It's a big number. You may have Googled it already. You might already know, and you might wonder why it matters. The number is 1,000. There aren't 1,000 little symbols here. It's a lot, but I didn't want to waste everyone's time. You can have 1,000 IAM roles per a single AWS account. That's the default maximum. That actually is plenty more than enough if you happen to have one per auto-scaling group. Perhaps you've got 200 auto-scaling groups in a region. And that's actually a lot, right? That's a high limit. So you can imagine my surprise when we hit that limit, because that's very strange. So now you might be wondering a little bit about who I am. I'm Sunil Chopra, as the previous card said. There's my Twitter handle. I'm a principal engineer at Jellyvision. And a little bit about Jellyvision. Jellyvision is a software company. You might be familiar with Jellyvision as providing a little bit of love during open enrollment, which is an insurance and health benefits annual. It's a special time for basically all American employees. Jellyvision has a product called Alex Benefits Counselor. We also make other things, but that's probably the most familiar thing. And we use Terraform for just about everything. And we generally use it for AWS, and we are also hiring, I have to say that. We're hiring senior DevOps engineers, engineering managers, senior software engineers. But now I'm going to continue the story about why this big number of IAM roles was a problem and what this has to do with Terraform. So just to set the stage a little bit more, rather than just a little scare tactic from earlier, why did we have this problem? So the origins go back to several months before we ever knew that this would be a problem, as most problems do. And I've got the benefit of hindsight to fill in some gaps. I'm going to do a little bit of that. For years, we had been supplying prefabricated Terraform templates for standard application patterns to the application development teams. And the teams were able to work within this world with a couple of customizations. People were always looking for more flexibility. And there was a little bit of a transition and a maturing inside of our organization, where the DevOps engineer role was sort of transitioning a little bit more into an SRE role, where there was direct engagement with an application team and less of like a separate team. So this was a great opportunity for things to accelerate to a certain degree. We were able to, in a cross-functional team, take advantage of Terraform operations within pipelines. And this was actually particularly germane to a certain team that was always doing something outside the box. Like, we had these templates, they were effectively cookie cutters, but the data team couldn't fit within those cookies, or they didn't like the taste of them, or something like that, to some kind of metaphor. The data team always had sort of special requirements, where another application team might be simply satisfied to have an auto-scaling group with EC2 instance or maybe a container based autoscaling group. The data team always needed something else, like maybe a highly scalable Lambda, perhaps something that's integrated with another service, where application teams were satisfied to accomplish log aggregation using the available tooling that we all used with Sumo Logic. The data team might need to actually build their own log collection pipeline of sorts, so they can pull in customized user analytics for later analysis, which is actually very important. The cookie cutter doesn't work. The data team needed special solutions with infrastructure, and for that, this direct engagement was actually a really great opportunity for that particular team to work a little bit faster and sort of polish their art in a pre-production environment. We wanted them to use infrastructure as code. We're using Terraform already, so we got automation involved, which of course makes things a little bit faster. Faster is good, right? We use Jenkins for this. We use Jenkins pipelines. This is the ones that are in version control, the Jenkins files. And with these, we're typically releasing code. Of course, we're also releasing infrastructure as code, which is neat. This is awesome. Things are sounding good. In Jenkins, we also use the Bitbucket branch source plugin, which provides a really excellent bi-directional integration with our VCS, which was Bitbucket server. So we'd automatically get a pipeline for every branch. In fact, we'd actually get like a folder for every repo within a project, which is great. And then build statuses from those pipelines would report back to Bitbucket. Great. These weren't always as polished as could be, but this was a really great integration that let people do things like run tests and even continuous integration, and to some extent we can trigger subsequent deploys with approvals and whatnot. But in trying to accelerate, we also wanted more Terraform execution, in particular pre-production Terraform execution within these pipelines. So we created this a little bit of a library that could execute inside the pipelines that utilize Terraform workspaces to keep state neatly separated. This is really great, possibly a familiar story. But of course, what this means is we're creating more resources. So we have to be very cognizant of where these go. And you might be imagining now where this story goes. We had to clean up. We didn't want to do a Terraform apply and then immediately destroy, because we want the engineers who are working on the pipeline and creating this dev infrastructure needed to see it, and they needed to see it for perhaps a little bit longer than the time it took to execute the pipeline. So things were applied and not destroyed. Later, there was a cleanup. How was that accomplished? So we figured that we needed to keep track of the Terraform configurations that were actually executing the Terraform applies. And for that to persist through the lifecycle of Git machinations, we used Git tags. Annotated Git tags within our VCS meant that if the branch was deleted, or ultimately a feature branch would have been merged, the branch is gone. We actually still have a record of what it's like a snapshot of the repo at that time because of the tag. So this worked. These annotated Git tags were generated at the time of Terraform apply, and they were pushed back into Bitbucket server. Problem was solved. Deletion of a branch wasn't really a problem, and we had a cleanup job that was able to go find those tags and delete the resources on a schedule periodically. So things were great. The machine was running. The sky was blue, the sun was shining, and nobody had COVID. At least not, it was like a year ago. It was great. More than a year ago, I don't know. The system seemed to work, and developers were free, and things were, accelerating. People were able to make their changes fast. And the experiments were periodically cleaned up. Right now, if you are feeling like this is sounding a little too rosy, you've probably heard stories like this before. Your instincts are keen. You are correct. Things got a little bit complicated. So going back to this diagram, we had pipelines for every branch, but we also had pipelines for pull requests. So just as a little bit of a tangent, this became very important as we were sort of dissecting this problem. Why do a build or a test on a pull request, you might wonder, especially when it's like the same as a feature branch. In this simple diagram, it would basically be the same as a feature branch. The head on the feature branch is basically merged into the target branch, and that becomes the same head because nothing else has changed on the target branch. But that is not always the case. Oftentimes, like maybe 20 to 30 to 40% of the time, Other things are happening. It really depends on, how active the team is and what the repository contains. But there might be other features happening. There might be hot fixes. There might have been some other Git operations of any sort on that target branch. And if the feature branch that you're going to merge is not the same, has to play catch up just to an extent. If that merge is like meaningful, then you get into a realm of what's called speculative merging. And this has nothing to do with Git conflicts. This is a matter of basically trying to figure the state of the eventual consequence of the merge. So good CI tools do this. They do speculative merging. Jenkins does this. The speculative merge within the realm of Jenkins does a merge to figure out what that end state's going to be, and it runs the test on that, which is valuable. That's actually a better test. And so subsequently, we would actually have the Terraform apply run on that, which again was actually valuable. And then we had the Git tag generated on that. And maybe you're beginning to understand why this is a problem. Going back to our whole Git tree here. Again, in a simple operation, if we're doing a merge from a PR on a small, short-lived feature branch, like is seen in this green circle, it's not a big deal. There's not, the speculative merge is the same as what would eventually be the merge, the consequence of the merge. It's all the same. But over here, you can see a little bit more complicated situation arises. This is where the speculative merge is distinct. And so what that means is that when the tag is generated, it fails to push because the hash doesn't exist on the remote, and it actually never will exist. So the job fails. As things progressed over time, these failures seemed to be curiosities. It wasn't very clear why the failures were happening. It took us sort of a long time to sort of unravel this situation with speculative merges. And the feature branches were ultimately disappearing because it was obvious to everyone that the feature was was functional enough before the PR was made, so the failure was ignored. Feature branch disappeared, but now we're talking about a Terraform apply has happened without a Git tag to keep track of the configuration. So things ultimately stopped working. The automated cleanup jobs failed, and resources started piling up. And eventually developer speed decreased, which is bad. That wasn't the point. We were trying to make things go faster. So let's take stock. What are we talking about here? We tried a thing that really helped devs move faster. Faster releases, better pre-production testing, and by some perspective, I think we actually were able to accomplish some interesting career growth opportunities. We're actually doing a bit of a shift left thing, a self-service thing, getting Terraform infrastructure manipulation into the hands of folks that would just generally be application developers, doing Python work or whatever. And this is great, except there was obviously a downside. We were creating excess AWS resources. Quota limits were being hit. And we didn't have Terraform configurations to clean this up. Now, cleaning these things up without Terraform is feasible, but you have loose ends. And it's certainly a lot cleaner if you can clean this up properly. But we did have plenty of state files. We used workspaces and kept them in distinct paths within S3. That was the classic remote that we were using to hold state. So let's be honest about what we're talking about here. Was this ever a graceful solution? We were leveraging Git tags to keep track of configs. I don't think it was really a great strategy because what we were basically doing, a little bit of an Ouroboros. We had an automated system that was triggered by Git activity within VCS, then turning around and pushing back to Git. We were careful enough not to create an endless loop, but the system did require a little bit of an abuse of what Git tags are actually supposed to mean, and especially if we're using Git tags for releases. These extra little Git tags are sort of polluting the whole Git history. It also meant we had to maintain extra service users, and worst of all, I believe it created a bit of a misplaced incentive. The shared tools team, who governed Jenkins and the AWS accounts, had a clear incentive to keep these usage quotas in the same place, and ultimately they were accountable for abuse of resources within the cloud. But the failure of the automated cleanup jobs was not something that shared tools was generally aware of. The reports would come, and it would only really be an issue when it was like a real issue, when the machine was screeching to a halt. On the other hand, the engineering team here was really only incentivized to move faster and develop new things. And when these failures happen, they would communicate a little bit about it, but they perhaps didn't understand the deeper importance of what that meant. And in many cases, they lacked the permission or the skill set to dig deeper into the problem. And ultimately, the product motive for the application team is just moving fast, and it's not, uh, sort of taking apart what to them did not seem like a real obstacle. So is there a graceful solution? There's probably something that you know better, but I'll tell you what we figured out. We had a Rube Goldberg machine, and it was fragile in ways we didn't realize. So we wanted to still have this freedom, but we wanted to do this in a way that worked. What we ended up finding was the magic of nothing, a blank apply. What we were really after was the destruction of what had been created from a Terraform configuration. And we got bogged down trying to keep track of what was in the configuration. But we always had the state. Was there any value in keeping track of that configuration? No, the real value is the magical emptiness of a blank configuration. And I will explain why. Consider a very simple case here. If you have a Terraform configuration that simply asks for 2 EC2 instances, you'll apply it and you get those EC2 instances and you get them added to state. And this is all quite logical. This is good. What happens then if you want to remove a single EC2 instance? You can remove it from your config. Then you run Terraform apply and it's gone. One of them is gone from the cloud and one of them is gone from the state. This is all quite sane. So what if that config gets emptied out entirely? Everything's gone from the cloud and everything's wiped out of the state if you're in a Terraform apply. So what happens if you've got like a cornucopia of AWS resources that are just there in the cloud and equally recognized in the state, but you don't have a config? What if your config is already empty and you apply it? They all go away. All of those resources are destroyed. The ones that are referenced in the state are destroyed if you're actually pointing to that state file. Now this seems a little bit goofy. Why does apply destroy? Of course it should. It needs to change, and change sometimes means destroy. Does destroy apply? No. Does untaint taint? No. Does import export? No. None of these things. I'm not crazy. You're not crazy. It's right there in the documentation. Maybe in a place that's sort of overlooked, perhaps a little bit between the lines. Apply does destroy in order to achieve the desired state. This, of course, is why you're asked to approve when apply happens, and you have to force if you don't want to do that. Interestingly, in the documentation about destroy, they sort of reference the theoretical possibility of doing this sort of weird inverse. The destroy behaves exactly like deleting every resource from the config and then running apply, except that it doesn't require editing the configuration. Of course, in this situation, what if we didn't have a configuration to begin with? We can just make a configuration that's blank and then execute that, right? Yeah, so why is apply better than destroy at destroying? Well, destroy requires a configuration that matches state, and it at some level, I think it also has to match the log file, the hash, the MD5 hash that's stored there. And apply in this way actually doesn't require anything that matches anything. You only need your single Terraform operation to reference the state file in question. Is this a blessed technique? I would say probably not, but it absolutely works with some caveats. So how is this going to fail? This time you should be asking this, and I'm going to pretend you're asking, and I'm going to provide an answer. So providers are a potential issue, but it turns out we can actually overload providers. Terraform does not care at all. You can put Terraform, you can put a template provider, you can put multiple AWS providers. Your quote unquote blank configuration can include many, many references to the same provider by different names. Ultimately, Terraform does not care. This makes it more versatile for using a single quote unquote blank configuration to clean up multiple such messes like this. The bigger issue we had was with modules. Terraform is sensitive to the fact that some resources in its state are created within modules, and simply dropping a module from a config is actually not sufficient for that. So dummy modules. The source in a config like this can easily just point to another equally empty config file, empty main.cf, in a path and call it a module. It doesn't matter where that source is as long as the module has the right name. And just like with the providers, you can just load this up with tons and tons of modules. You could have 20 providers and 100 module references and it's fine. And that blank config actually can continue working for things that don't have module references, because these module references are empty. They have no resources. You're not accidentally going to create something. It turns out when all you want to do is destroy, it's really easy. It'll just destroy everything in the state once you have all these module references in there. Really, really handy. So we called this Tarkin because the idea is that if Terraform creates worlds, then the Death Star blows them up. But the Death Star is Terraform because that's actually what's doing the destruction. So this is Tarkin. It's telling the Death Star what to do. And here's a gratuitous Star Wars GIF in case you weren't sure exactly what the Death Star did. I just like to watch this every once in a while. It's really lovely. So that's the end of the story, except back to the beginning. Perhaps you remember something about IAM roles. Things are better now, right? Here's the punchline. When this problem became, a really big problem, when we hit that quota limit, we did the more obvious thing that you might expect. We actually just asked for a quota increase from 1,000 to 3,000 because we believed that would be enough. We knew we couldn't get this cleaned up fast enough. We didn't want to slow down the devs. We hit that limit again last week. We hit 3,000. So the maximum limit is 5,000, and we'll get this taken care of pretty soon. Now that we've got the tool, and now we know the technique, and now so do you. So I hope this has been informative. Thanks. I think I'm going to stop sharing my screen.
Hello, hardware mute strikes again. I was saying, I love this talk. It was so fun. The examples are great. And I think you asked like a really good question there in terms of like, we tend to try to keep everything in case maybe we need that log file or maybe we need that configuration file in the future, but maybe we don't need to. I think it's a great thing to think about that. Just checking to see if we've got any questions. There is no questions coming in on YouTube. Yeah. Let's see. It's very quiet in chat today. A comment did just come in that says that they really enjoyed this one and that you did a great job. I thought it was great. I liked the examples. It was fun. You kept it like a quick pacing. This was fantastic. I really enjoyed it. I'm gushing about your talk too much.
Cool. I'm glad you enjoyed it. I can talk more if there's time to kill. I'll say that, as I said in an early slide, Jellyvision's hiring. So please reach out to me. I'm on Twitter. Also, you could probably just go to our webpage and there, LinkedIn and things like that. So reach out.
Which part of the whole process, I guess, you talked about what was your favorite thing to do? I have to ask.
It's absolutely completely meaningless to say this, but my favorite thing was naming it Tarkin. I just love Grand Moff Tarkin. From a technology perspective, though, my favorite thing was honestly just making it work. And as a part of this, one of the things I sort of glossed over, what is it that we're calling Tarkin? It's not necessarily the technique. It was actually kind of a tool. It's a bash script because it's really just executing Terraform commands with a couple of sanity checks. And we had a little bit of a test put together and like making sure that the test worked and making sure that we cleaned up this. We actually had to remove the state file after we blew everything away because just in case that feature branch was used again. And we had to also remove the lock file. Adding those little bells and whistles into it was it was gratifying in a way because it sort of proved that this was handy, and we were able to remove things that were really troublesome to us otherwise.
That makes sense. I'm like a huge fan of like nerdy names that give you an idea of what they do. Having named our like artifact repository cluster we spun up Smog in the past because it's the dragon that keeps all the gems. So that was probably I was like, that's a highlight for me from your talk. But yeah, I think we've got 5 minutes left. Is there anything else you'd like to say?
I'm trying to think of what. I'll say that thanks to, I think I said this before too, and I just want to make sure that I get this across. Thank you very much to the Katie Reese and yourself and the community have done a really great job of organizing this. Even the little the speaker card and the templates was all very nice. Made it a lot easier. And I felt like I got a lot out of if other people are like listening and sort of perspective for the next year or something. I got a lot out of that speaker training session. I felt like that really helped me sort of bring the story together, and from the beginning to the end with sort of like a through line.
Thank you. That's really nice to hear. And I think I like the speaker training too. I went to it last year as a new DA, and it's been really cool to kind of see these things happen and to have people come in and to be able to share these experiences, but also for us to be able to help support, because it is hard coming in and doing a talk. So yeah, thank you so much for joining us today and for being here and sharing experiences and your story. And hopefully we'll see you again in the future. Well, I'll see you again in the future. Words.
Yeah, yeah.